Hi, welcome to my video. For this week's lab 3, these are all the things we're going to go through in this video. And let's do an introduction to this week's lab 3. And we know that from the lab instruction, a star is obtained a black hole, and we need to analyze the net force parallel, and net force perpendicular on the star. In this case, we will have to know the Newton's second law. From Newton's second law, we would have to know the rate of change of the momentum. So these are the useful formula we will have to know. From the Newton's second law, we know that F net is equal to rate of change in momentum, and this rate of change of momentum has two components. One is parallel and one is perpendicular, which are the same as F net components. And so from the computational model, we will easily see that we can separate our F net to two components, and these are what I have for my code. And you know that we will finally get a dynamic graph showing the trajectory of our star, and it is affected by this violet arrow, which is F net parallel, and this yellow arrow, which is F net perpendicular, and the cyan arrow is our F net. So we can easily calculate the dp dt, which is this cyan arrow, and then we can get our other two components. While I am talking about this, let's go through the code. And I changed the seed here to my email, and let's run the code first, and I will explain details of my code. Here here you can see what I changed in my code. I changed the dp dt, which is our delta p delta t, and F net is equal to dp dt. And for the into the trajectory, when it finally finishes the circle, finishes the orbit, we get these data, which tells us radius and the F net and dp dt. Then we can calculate our mass of black hole, which is F net equal to F gravitational, because we only get one force exerting on the star. That's F gravitational between star and the black hole. And then we can just put that in our formula from previous weeks. Like we know that the gravitational force is equal to F net, which is equal to mm times g divided by r squared, and we manipulate the formula, we'll finally get the answer, which is 3.45 to the times 10 to the power of 21 kilogram. And for the follow-up questions, we know that dp dt is an approximation of F net. So mathematically, there's no difference between dp dt and F net. And you can see from the calculation here. However, there is one main difference, is that we can calculate the dp dt using velocity and mass directly, but we cannot directly get the force we have. So in case to get our force, we need to firstly calculate the dp dt. And if the black hole is replaced with a new one and the motion of star is unchanged, the mass of value is unchanged, because we only have one gravitational force on between black hole and the star. If the motion of the star doesn't change, the gravitational force will not change. And since the mass of star is not changed, the black hole will stay safe. Otherwise, the motion of the star will have to change. And that's it. Thank you. Thanks for your time.